a little review question just to solve this is just a quadratic equation. So I should have two answers, right? Do you guys, you cannot factor this. So kind of really two options here. Do you guys want to do completing the square, or do you want to do quadratic formula? Or do we care? Okay, let's do the quadratic formula then. Okay, so I'm going to do opposite of b, which would be positive 8, plus or minus square root, and then let's just speed this process up. I'm just going to do this on my calculator. Okay, so we'd have b squared, so negative 8 squared, 4 times a value would be 1, c value would be 9, right? So I'm just typing this in. Under the square root, we would have 28. And then on the bottom, we would have 2a, so it would just be 2 times 1, so that would be 2. Now, 28, not a perfect square, so we want to see if we can break that down a little bit. So if you want to do factor tree, please feel free. Does anybody know, though, the biggest perfect square that would divide into 28? 4. So if it was me, I would just real quick rewrite that as 4 times, it has to be multiplication, 4 times 7. Then you can actually just remove the perfect square. So square root of 4 is 2. 7 left underneath. I'm just going to slide this back over and replace that. So it would be 8 plus or minus 2 roots of 7, everybody over 2. Can I simplify that, what I got there in any way? We can divide, okay, now don't be touching that radical. All 3 of these have to be divisible, so you can do that here. So it should just be 4 plus or minus. Now, 2 divided by 2 would just become 1. You're not going to see that written in front of the radical. We would just write it as 4 plus or minus radical 7. Okay, now, I'm just going to emphasize this because it goes along with our theorem today. So this really means 4 plus the square root of 7 also means 4 minus the square root of 7. These would just be, like, you could type this on your calculator if you wanted to. If we put this on Desmos, you'd see this is where it would cross the x-axis, but you just do 4 plus radical 7, 4 minus radical 7. Those would be approximate answers. They're nasty decimals. Whenever you have a square root, like I have a square root of 7 here, that is not a perfect square. So if it was 25, we wouldn't be having this conversation under our square root. But anything that's not a perfect square under your square root is going to give you an irrational number. Irrational, does anybody know what that means? Right, it goes on forever, it has no pattern. What were you going to say? Yeah, I was going to say, no, okay, so like pi is an irrational number. If you guys have ever seen like all the digits of pi, there's no kind of pattern to it. The other thing is you can't write it as a fraction. And actually, let me just show you on my calculator. Okay, you know my favorite button is math, enter, enter. If you have an irrational number, if I hit my math, enter, enter, it will not convert it. So that means it can't be written as a fraction. If you tried to type pi and convert it to a fraction, it won't do it. So an irrational number is just any number that is not a perfect square under a square root will create an irrational number. It's a decimal that goes on forever with no pattern. It cannot be written as a fraction. Okay, so these two would be my zeros. So that's just what this says. The roots or zeros of a polynomial makes it 0. If we plug that in for the x's there, it would make that equation true. Now, irrational, what we call conjugates. They're basically identical, like these are identical, but one has a plus and one has a minus. So that's what a conjugate looks like. The actual definition, you're going to see it like this. They would say a plus the square root of b and a minus the square root of b. That's kind of the, I'm not on the screen, fail. That's the format you would see them in. So like in my little example we just did above here, it would be 4 would be a and 7 would be b. So those are called irrational conjugates. B could not be a perfect square. I don't know if you want to write that, because if it was, then it would cancel the radical. Any other number that's not a perfect square will cause you to have an irrational answer. Okay, so here's the deal. The irrational root theorem is going to say to you, and this works both ways, it's going to say if a plus the square root of b is a root or 0 or whatever you want to call it, I'm going to call it a root here, then automatically its conjugate, which would be a minus the square root of b, is also a root. And you guys can see, it would basically be the argument, us using the quadratic formula every time I get two answers here, and as long as there's something left under the radical, that creates an irrational number, and you always have the plus or minus, so you automatically get those conjugates, so you get the two of them. So if one is an answer, automatically the other one is two. Now, does anybody have a question so far? Okay, here's how this works. So this is just going to say, if this is going to give you a list of numbers, and it's going to say this is a zero or a root of the polynomial. And then it says find any additional roots. Okay, so if you can find a conjugate, if you have an irrational number, you can find a conjugate, then you would automatically have another root. So like this one says 2 minus radical 5, then automatically 2 plus radical 5 would also be an answer, automatically. Okay, this is kind of tricky. Does the square root of 7 have a conjugate? All right, this is a little bit weird. If I thought about this like 0 plus the square root of 7, it does have a conjugate. As long as you have a radical, you have a conjugate. I would just write it, I would not write the 0 in front of it, but anytime you have a radical, it does have a conjugate. So negative square root of 7 would automatically also be a root for that one. Okay, now all I want to do is emphasize this for this question. I give you 3 answers. I say 4, -3, and 0. Would I have any other roots? No. Okay, these are not irrational. So don't just go, oh, 4 is an answer, so -4 is an answer. It doesn't work like that. A conjugate has to go with a square root. These do not have conjugates. They have opposites, but they do not have conjugates. All right, the one right next to it, this always trips people up. You only, if you have an irrational number, 2 parts. I've got -3 plus the square root of 11. It does have an additional root. It's conjugate. You only change the sign in the middle. You do not change that -3 out in front. So a conjugate, it's just change the sign in the middle. If it's a plus, then you change it to a minus to get the conjugate. If I have negative square root of 29, its conjugate would be positive square root of 29. All right, 16 is a plain number, does not have a conjugate. It has an opposite, so we don't get anything else from the 16. But if you have 4 minus the square root of 2, automatically 4 plus the square root of 2 would also be an answer. Is anybody having a question about that? If it doesn't have a radical, it doesn't have a conjugate. Okay. Now, here's what we're going to do with these. I'm going to have you guys basically work backwards today. I'm going to give you the answers, and you're going to write me the polynomial. And we're going to write it in standard form, but I'm going to start with factored form. Okay, so here's what this says. Write the polynomial in standard form with the given roots. So it gives me 9, and it gives me a square root. If you see a square root that's not a perfect square, automatically you're going to get another one. So this says negative square root of 3. So even though they didn't type it in the problem, I automatically also know that positive square root of 3 is going to be an answer. Okay, so we're going to write this. We're going to start in factored form, and then we'll go to standard form. So if 9 is one of my answers, one of my zeros, one of my roots, whatever you want to call it, what would be the little factor that would go with 9? X minus 9. Okay. Now, if I told you negative square root of 3, they gave that to us in the problem, how would you write that in like a little set of parentheses? If I told you negative square root of 3, how would you write that? Exactly. This just treat it like it's a normal number. If it's negative, like this is minus, just do x plus square root of 3. For the positive square root of 3, you would do x minus the square root of 3. So this guy that we just wrote out, we took care of all of those zeros. This would be your factored form. And ultimately, the question wants us to do this in standard form, so I got to get rid of all the parentheses. Now, here's the deal. If you have irrational roots, you have not seen a bunch of square roots as coefficients or anything like that in any of the polynomials we've worked with. So when you're working with this, they do cancel out. You want to multiply these together, but here's what I want to tell you. If you have a problem where you have conjugates, we're going to FOIL this whole thing out, put the conjugates together first because all the radical parts will cancel out. Okay, one's a plus and one's a minus, as you guys can see there. I promise all the radical parts will cancel out. Now, when you do this, just do like little FOIL. If you want to do a box, you can do a box. Just x times both of those terms. So you'd have x times x is x squared. Now, you're going to get x times the negative square root of 3. What I would do to write that, I would just write the x in front of the radical, so that way people don't confuse it and think it's under the radical. So just write that out in front. And then what's going to happen, though, is I'm going to turn around and get the opposite of that, because we're going to do positive square root of 3 times positive x. So this would be plus x radical 3. These two guys are going to cancel out, so you're not going to have to worry about that. Now, what do you get if you take positive square root of 3 times negative square root of 3? What was it? It would be negative 3. Okay, if you're like, what the heck, where did you get that? Right here, positive times a negative is a negative. If you multiply a radical by itself, it creates a perfect square. So that would technically be square root of 9. And then it has a subtraction sign in front of it. So it's x squared, that would simplify to be just minus 3. All right, now, the other 0 they gave us was 9. So the little linear factor that would go with that would be x minus 9. So to fully get our polynomial, I got to do one more little FOIL here. So x times x squared, we should get x cubed because we had 3 answers, right? So this would be x cubed, bless you. X times that negative 3 is negative 3x. Negative 9 times x squared is negative 9x squared. And negative 9 times negative 3 should turn into positive 27. And then, you know, we just got to be a little picky about this because this is not in standard form. I just have to switch those two terms to write it in standard form. So standard form would be x cubed, put the minus 9x squared next. We want our powers of x to go down in order. Then negative 3x, and then the 27. Is anybody having a question? It's not bad to do. You're basically just going to do a bunch of foiling today. Okay. Now, this guy, maybe. Now, this is a little trickier. So, remember that very first question, we got 4 plus or minus the square root of 7. So this is going to be kind of similar to that. This is just different numbers. I've got 5 plus the square root of 6. So automatically, like if we had done the quadratic formula, we would have gotten 5 plus or minus the square root of 6 on this polynomial if we had solved it. So if x, or 5 plus radical 6 is a root, automatically its conjugate 5 minus radical 6 will be also. Okay, I'm just going to show you how to do this because this is kind of weird. If you set this into a little linear factor, this is tricky because it has 2 pieces. Here's what I'm going to tell you to do. No matter what, just do x minus, and then you're going to just put that 0 they give you because it's an irrational number. We're just going to put that in parentheses. So no matter what, just put a minus right there. Just x minus whatever they give you. Okay, now think about that for a second. If I went and took 5 plus radical 6 in for this x, right? 5 plus radical 6, and then I subtracted 5 plus radical 6, that would make that 0. So that's why you just use a minus every time. The other little factor, the same thing, doesn't matter even though I'm going to change this up to the conjugate. I'm just going to put x minus, and then let's see, what do we have? 5 minus the square root of 6. Okie dokie. Now, here's my recommendation to you. We got a lot of parentheses going on there, yes? So before you try to multiply anything, let's get rid of this extra set of parentheses in here. I want to subtract both of those pieces. So basically what I want to do is just run a -1 through both of those terms. So just to simplify it a little bit before we multiply, it's going to be x minus 5 minus radical 6, and then you're going to have x minus 5 again, but then it would be plus radical 6. They'll always be in that format. One will be a plus and one will be a minus. I'm getting the plus here because I'm doing minus and negative. So like a -1 times that negative radical 6. Okay, now, this is tricky. I promise all the radical parts will cancel out if you do this correctly. This is just my thing. If you want to do FOIL, you got to do x times all three things, -5 times all three things, and then negative radical 6 times all three things. For these types of problems, I personally use a box just because there's so many terms. So I'm just going to do that here, and then I will show you that you can kind of skip a step if you understand this. All the radical parts are going to cancel out. You're not going to have any square roots when you do this. So I'm going to write the x minus 5 minus radical 6 down the side, and I'm going to write x minus 5 plus radical 6 across the top. That does not matter. Okay, just to help me organize. Now, I'm just going to get, like, this will be x squared minus 5x, and then this will be x radical 6. Then I'm going to get negative 5x positive 25. Negative 5 times radical 6, just put a negative 5 in front of a radical 6. Then down here I'm going to do, this will be negative x radical 6. This negative times a negative is positive 5 radical 6. And then down in the corner, negative times a positive will make this negative, and it would be negative square root of 36. Now I kind of wrote that small. That really means this box is negative 6. Because you'll always end up with a perfect square in that bottom corner because you're going to do whatever, these two will be the same number, so it'll turn into a perfect square, and it'll always have a negative in front of it because one of them will be positive and one of them will be negative from the conjugates. Okay, now here's the deal. And if you like this box and set it up this way, this one and this one will always cancel each other out in this box, and this one will always cancel each other out. So you have these four, and then you have this one down here in the corner. So all we're going to do, these don't cancel, these are both negative 5x. So this would be x squared minus 5 would be minus 10x. And the only thing you really have to pay attention to, you're going to have the plain number in the middle, and you'll have that plain number in that bottom corner. So you got to put those together. 25 minus 6 would be 19. And I know that's a lot of work, but that quadratic, if we did the quadratic formula on it, or if we wanted to do completing the square, those are the two solutions we would have to that equation. Is anybody having a question? Okay, I'm going to do one more with you. This one's a little trickier because you have an actual 0 also that's a number. So no conjugate for negative 8. That's just a plain number, no conjugate. So x plus 8. So I'm not going to write any additional root from that negative 8. The other number, we've got negative 2 plus the square root of 13. Do not change the negative 2, just change the sign in the middle. But if you're working with a radical, it has a conjugate. So I'm going to write down just change up that number in the middle. Okay, now, no matter what, I promise you, just use x minus, no matter what, and then put whatever you had as the root with those two pieces, just put those two pieces in parentheses. It doesn't matter which one comes first or second. All right, I always use a minus. And I promise, if you plug in the root that they were giving you for x, it would simplify to be 0 inside the parentheses. Now, before you try to multiply anything out, I would get rid of this extra set of parentheses that you have here. Just do a little distributive property, just running a -1 through there. So I'm actually going to get x plus 2 minus radical 13 and x plus 2 minus, what did I just do? This would change. Oh crap, I wrote this as a plus twice. I'm sorry guys, this should have been a minus. I'm sorry. Okay, so one should be x plus 2 minus radical 13, the other one would be x plus 2 plus radical 13. And then I'm just going to rewrite this x plus 8 real quick. Now, if you're working with conjugates, multiply those together first because all the radical parts will cancel out. Now, here's what I do when I do these problems. Okay, so you guys saw my little box that I drew above there, right? I do not even fill in those boxes. I don't even do it. I just leave that alone because I know they're going to cancel out. So I've got x2 and negative radical 13 down one side or across the top, and then I've got x2 positive radical 13 either down the side or across the top. I put the positive 13 across the top. Here you get x squared, 2x, 4, and then down in the corner, the other ones I don't even do them because I know they're going to cancel out. It's just these 4 boxes and this one in the corner. Negative root 13 times positive root 13 would be negative square root of 169, which it's a perfect square, so it's just going to end up being negative 13. All right, so you got 2 numbers. You got the 4 in the very middle, you got the negative 13 in that corner, and then the other ways we're just going to combine like terms. So I still have the x plus 8. I haven't used that yet. And what I have left here, I've got x squared, 2x and 2x. They don't cancel. It'll be 4x. And then I have 4 minus 13, those 2 numbers there, so that'll be negative 9. And then ultimately, I just have to do another step to get the actual polynomial that has all 3 of these roots. It should be x to the 3rd when I get done. If you want to do a box, you do a box. If you want to just kind of do FOIL on steroids, that's totally up to you, whatever you prefer. But you should not have any radical parts once you get to this point. After you multiply those conjugate factors together, all the radicals will cancel. So these should all be nice plain numbers, all right? So I'm just going to go ahead and do like a kind of a double FOIL. So I've got x, whoops, I just wrote that wrong. We got x cubed, and then plus 4x squared minus 9x. And then I just line up the like terms. So 8 times x squared would be 8x squared. Just put it under the 4x squared. 8 times 4x is going to be 32x. And 8 times negative 9 is negative 72. So my actual answer here, I'm going to get x cubed plus 12x squared plus 23x and then minus 72. The key to these, though, for the conjugates, multiply those together first. If you have to write the polynomial, then all the radicals should cancel out. Is anybody having a question? Okay, good. We got plenty of time today. Let you guys start working on